Multiparadigm Data Science with the Wolfram language. Section 2, Getting Your Data into Shape. In this section, we are discussing functionality that is useful for data wrangling. Stephen Wolfram recommended a 10-step data curation hierarchy on his blog post a while back. It shows a path to get data from the raw digital form in which it has been collected to a form suitable for repeated systematic computations. Integrating it into the multi-paradigm project workflow, we now have a helpful guideline for the data wrangling stage. Steps 2 and 3 here highlight the need to wrangle raw data and store it systematically, with the data elements arranged in a structured way. The structural elements that can be used for organizing data include lists, associations, datasets, entity stores, and time series. Lists are among the most basic data structures. In fact, most file formats are imported into lists by default. Let's take a peek at this list to see the first few rows of the data. Nested lists provide a structure similar to rows and columns of tabular data. The 601 rows of the tabular data here have become the list of 601 inner lists, and the 3 columns correspond to the 3 items in each of these lists. Here's the first row, and here's how we can look at the rest of the data. Here's a look at columns 1 and 3, or if you choose, we can look at columns 2 and 3. Lists can be easily manipulated for inspection and computation. The only overhead that we need to keep in mind are the indices of the elements in the list, so we can retain an understanding of the original structure. Column 1 here has the cities, and column 2 has the sales amount. So if we want the total sales for each city, we'll need to work with column 2. Associations reduce the need for this overhead to keep track of the indices. They use key value pairs to represent the data. So we have this dictionary data structure where each value is labeled with a key, and this key is also used to access the value. This removes the need to remember the meaning of each entry and strictly adhere to the sequence of indices as we had to do with the list. We can work directly on the values of the association, or if needed, we can also work on the keys. We can extract all the keys or all the values from the association. It is easy to construct associations from lists, and we can get back a list of the key value pairs from the association if needed. So here's the sales data from the previous example, but this time let's use an association to store the sales for each city. Now we can retrieve the information for a specific city and continue to be able to work with the data for all the cities in the association. A dataset is a general way of representing a hierarchy of lists and associations constructed from tabular data. It provides a flexible framework for sophisticated database-style queries and manipulations on data while providing a defined regular structure at arbitrary complexity. We can extract rows or columns from the dataset, query it using a function or composition of functions, as well as sort, filter, and aggregate rows in the dataset. Revisiting the sales data example, here is a dataset of sales figures with the cities in rows and months in columns. And this is how we could query it for information. Semantic import gets the data directly into a dataset, and while doing so, it also uses machine learning to automatically convert different kinds of data into Wolfram language entities. For data ordered in time, it is helpful to preserve the essence of this special ordering property. A series of time-ordered data points like the monthly sales of the Boston office in the sales example can be stored as a time series. We can now use special functionality dedicated to handling time series to explore and analyze this data. Here is a sample forecast from the model based on the past data and a comparison of the forecast to the actual data from this period. So the data curation hierarchy referred to earlier recommends converting data elements into canonical symbolic form of entities. This helps with augmenting plain data with additional information during the data wrangling process. The Wolfram language provides access to real-world objects as symbolic entities with their own set of properties. We can create a richer data set by converting the plain text representations of many data elements into computable entities, thereby really embracing the multi-paradigm approach to working with data. In addition to the built-in entities, we can create custom entity stores out of our own data. Here is an entity store of the type offices containing the same information as in the earlier sales data example. It has 6 entities of the type office with their own properties like city and total sales. This can now be used in the same way as built-in entities. You can find more information about setting up entity stores in this workflow and explore functions to work with information in relation database here. In summary, we covered various structural elements that can be used in a multi-paradigm workflow to organize and work with data. We looked at lists, associations, datasets, time series, and entity stores. We also looked at using the Wolfram Data Framework to enrich raw data semantically, a useful step towards preparing a structured computable dataset as the end product of the data wrangling stage of the multi-paradigm workflow. In the next segment, we will look at dealing with messy data, removing errors and finding replacements for missing values, all part of the process of getting your data into shape for exploration and analysis.